Stephanie Davis, and I will be doing a short video on an extra credit lecture for Physics 2212. And the lecture that I will be talking about is called Baseball and Physics. You can observe a lot by watching, and this was talked about by Professor Alan M. Nathan. So I attended this lecture because it sounded really interesting, because I myself am a softball player, which is a little different than baseball but has the same main concepts. So I thought it would be interesting to see a different point of view of what actually goes on, instead of when you're playing it you don't really think about the physics. So I even have my softball glove here, which shows that I actually do play. But the main topic of this lecture was that the dynamics of the ball and bat collision and flight of the baseball. So when you're going up to hit, the ball deforms when it hits the bat and bounces back with about half of the original speed that the pitcher threw the ball with. Newton's third law is also a big part of the physics behind pitching and hitting. And Newton's third law is that there's an equal and opposite reaction to everything that goes on. So as the bat is giving momentum to the ball is also giving momentum to the bat after they collide. So as you're swinging, you're giving momentum for the ball to travel, but you're also getting a resistance on the bat. Also, the speed of the bat matters more than the speed of the pitch. This can be easily shown through, if you're bunting. When you bunt, you're not actually swinging, you're kind of just holding your bat out in front of the plate waiting for the ball to hit it. So when you do that, the ball travels only a short distance, like a few feet in front of the pitcher, whereas if you were to swing the bat as a normal hit, you can end up hitting the ball out into the outfield or further away. And this can be done, like, you can have those two things happen with the same speed of the pitch. So that shows that the bat is more important, the speed of the bat is more important than the speed of the pitch. Also, it shows that as a lefty, I'm more likely to hit into right field, whereas a right-handed person is more likely to hit into left field. So when you're swinging on time, you should know that that's where your ball is probably going to go, and that's how the fielders know how to position and what to expect when you're hitting. So that also shows that how you're positioning your bat and how you're hitting your bat. If you're swinging faster, then you're going to have an earlier hit, which is going to bring it more to the side that your hand is on. Also, the bat slows down after reversing the ball's motion. So all the force you're putting into swinging the bat, it's still going to slow down because the ball is colliding with it and making it, counteracting your swing. So this energy loss with the collision of the bat hitting the ball is due to friction and thermal energy, and this is the friction of the ball hitting the bat, and also the thermal energy, which is the heat transfer from the two objects. And there's also air resistance also has an effect, because as you're pitching, you can't pitch fast enough to get rid of air resistance, and you can't swing fast enough to get rid of air resistance. So something interesting that he talked about during the lecture was that aluminum bats are better than wood, and this has always been kind of just a given for me when I've been playing, because we've never really, it's always been with aluminum bats. And but there have been times when we have used wooden bats in practice, and you can tell a huge difference, because when you're hitting with an aluminum bat, you feel like you're the best hitter in the world, and then when you switch to a wooden bat, you're like, man, I can't even hit to the first baseman. So, but you never really think about what that reason is for, and the reason of that is what he said to be the trampoline effect, which is there's less energy loss with an aluminum bat, because aluminum bats are compressed during the collision, but with a wooden bat, the ball is actually compressed instead of the bat. So with the ball being compressed, that's going to make your ball not travel as far, because that's the thing that's traveling. The bat isn't going anywhere. You're still holding on to the bat. So the fact that the aluminum bat can compress means that the ball can still go further. What else? He also talked about the sweet spot of the bat. And hitting the sweet spot of the bat means there's minimal vibration on the bat. And this is really clear if you've ever played baseball or softball, because when you hit the ball and you hit the sweet spot, you feel like you've almost swung it and hit nothing. Seems like as light as air, and then you look and the ball's gone like way out into the outfield, and you feel like the best baseball or softball player ever. And then if you don't hit the sweet spot, you would really notice it, because if you hit towards the far end of the bat, or if you hit too close to the handle, your hands are going to start hurting because of the vibration. And I always, as you learn to play, you always know that if you hit those spots, you're going to have your hands really hurting, and that's why you don't want to do it, but you never really know why. So this physics lecture showed that this is because of this certain sweet spot leaves minimal vibration, whereas the other parts are going to make the collision vibrate more, which puts more energy into the bat and will make your hit not go as far as it would if you hit the sweet spot. So, also, when you hit the sweet spot, it shows that nothing on the handle end of the bat affects the ball's momentum, because the ball is like already gone out into the field before the effect reaches the handle. So when you hit the sweet spot, you're having the least amount of energy loss, and you're getting the furthest distance of the ball to get out. So that's like getting a home run or something, versus hitting the end of the bat or near the handle and only getting to first base. So the point of that would be the sweet spot is the place to hit, which is a good reason why it's called the sweet spot. Something else that has to do with physics and baseball/softball is that there are different pitches. So as I said earlier, where the speed of the pitch doesn't affect the distance of the ball, whereas because the swing of the bat does affect that. There are different pitches that can change up. There's like a curveball and a curveball. So that's difficult, because when you're about to hit, you go up and you're like, okay, the ball is going to come straight in. So you're looking and it looks like it's right over the middle of the plate, which is where you want to hit it to hit the sweet spot on the bat. But then at the last second, it swerves out, so it gets to the opposite end of the plate, and that means you're probably going to hit it with the tip of your bat, which is going to then cause more vibration, make your hands hurt, make you have a crappy hit, and that's not what you want. So special pitches are done by the pitchers using different techniques with their hands and their wrist movements when releasing the ball, and these cause the ball to have an imbalance of pressure due to air resistance, so that changes the direction of the ball. So I found this lecture really interesting because it really connected what I do for fun to physics side of it, and it made me realize like why you do certain things you do, and that there's actually a meaning behind it other than, oh, this is just because this is what baseball is. So thank you for watching.